Version control systems are one of the most powerful tools you're going to have in your pocket as a software engineer. And you're going to spend a lot of time working with Git and other version control systems in the future, likely, because they're central to the development process of working on real projects and trying to do so in a safe way when you're collaborating with others. We'll talk about what I mean by safe, but the gist is you can try ideas out with a version control system without risking something that you know already works. So it enables experimentation and it enables collaboration in some really creative ways that are much better than just sending your files around loosely through email or things like that. So let's talk about what a version control system is and then more specifically about Git. Projects that are non-trivial pieces of software involve lots of files, not only your source code files, but your configuration files. You'll have build scripts, you'll likely have documentation. There are a lot of files that go into a modern piece of software and are all contributing in various ways. And not only are there a lot of files, but there are a lot of interdependent files, right? Like you're defining some functions or classes in one file and then making use of those as dependencies in another file. And so you want there to be a lot of consistency. If you're making some changes in one and that impacts other files, well, you want to be sure that if you revert one file, you're reverting everything that file would have impacted at the same time. And so version control system software is developed for this purpose, where we are able to checkpoint certain times in our project's development history such that when we make changes that are interdependent between many files, we know that we're saving all of those files in a consistent manner at the same time, at that point in time. So there are a lot of things that you really want to be able to do when working on software. You want to be able to try things out. So we call this refactoring. And the idea is you've got a project that's working. You want to either extend it or maybe redesign some of the internals of it. And you'd like to be able to do that without having any risk to what is currently working, right? You don't want to fix something that's not broken, but you want to improve it. And so version control systems give you an easy ability to try new things out. And if they work and you want to incorporate them back into the primary branch of your project, it's easy to do that. If you want to toss it out and say that was actually a bad idea, that's easy to do too. And you're going to have complete confidence that your primary project is not at risk. They allow you to review the history of work that's been done. So there are ways of seeing who changed this file, who changed this particular line of the file last, how can I go talk to them and figure out what was going on here. And when you have issues that arise and you're trying to find, well, what version of my software project did this issue actually start occurring in, there are tools for doing that with version control systems and finding when bugs first occurred. As I mentioned, there are complete snapshots that are points in time that allow you to go back to a certain place in the development of a project and work at that exact moment without fear that you're missing some files or you forgot to revert some files or not others. These are points in time where the entirety of your project will be made consistent. Additionally, software development often works in a versioned manner where there will be a lot of progress and then we'll say, hey, we're putting a flag down here. We're going to say this is version 1.0. There's more progress, minor versions get released, little fixes, and then another version gets planted, 2.0. And you want to be able to get back in time for someone who's currently working on version 1.5 of a project. How can you go help them out and try and see, well, is this actually a problem with our software or something else? Versions and keeping track of versions is in the name of a version control system, and there are ways of naming the versions that you work on. We'll see that with Git tagging later. So what else can you do, or what are some of the specific things that you do? Well, we tend to track changes over time in the repository that we're working in. So we call a project or a history of some directory or repository, and that repository can be made up of many directories. And we tend to have what we call these atomic snapshots that are points in time where we can revert back to them as needed. And what's interesting is you'll see that with a version control system like Git, people can be making snapshots working independently of one another, and then there are means for bringing them back together and merging everybody's work into a central place. Version control systems have specific workflows for how you share your changes with someone else. So you'll be working locally. How do you send this to your colleague to try out and get confirmation of? Lots of companies have processes in place where someone else has to say, hey, this code looks good to me. Google has a check that's called the looks good to me, or LGTM, that someone has to sign off on it before it gets merged into the primary branch of the project. Similarly, if you want to work with somebody else's code, check out their changes, maybe riff on what they're doing. There are ways of pulling changes down in working with other people's updates. And there are going to be policies and procedures that every project has in place for how to deal with conflicts and how to hopefully try and avoid conflicts. Because sometimes if two people are working on the same file, make changes in the similar places of the file, it's going to be on those people to resolve how do we get through these conflicts. One of the best features of a version control system is that it gives you the safety to explore without any risk, right? You can very confidently try new things out and know that you can always go back and you're not risking anything. You can delete all that you want and immediately return back. There are two models that tend to dominate version control systems, but in recent years, the distributed model of Git is more prevalent. So what that means is when you're working with Git, all of the history is local to your computer as well as everyone else who has the repository. And so you're able to work independently in a distributed way. And then there are certain actions that you take to send your changes up to a central repository or to somebody else's, and vice versa. This contrasts with what was more prevalent 10, 20 years ago, which was a centralized version control system where there was a central server, and anytime you wanted to work on some files or check out a new branch or something like that, your local version control software would have to go say, hey, server, I'm doing this and that. I want to get permission to do this. And it would check to be sure no one else has this thing checked out. And it was just a slower process for working with the version control system. And it turns out like distributed has kind of proven itself to be a much better system. In reality, we tend to use sort of a mix of these two things. Even though Git is distributed, we tend to use a central copy of or replica of our repository stored on GitHub or something else like it. And I'll talk about GitHub and some other services for hosting Git repositories later. We tend to have a central repository that's our origin or our primary repository is kind of centralized, but we still, Git is very much a distributed system, and you're working without going up and down to the internet unless you explicitly ask for it to. So what's so awesome about Git? And Git now is just the de facto standard, but it was invented in 2005 by Linus Torvalds. He took inspiration from some other version control systems that had similar properties, but were proprietary and very expensive. I think it was called Perforce. And Linus, who was the inventor of the Linux operating system back in the early 90s, and that's what powers Androids, Chrome OS books, most servers on the internet. And if you're running a Linux laptop, that would be running his code as well as the virtual machine that's installed in order for Docker to work. That's a Linux system, and Docker runs primarily on Linux systems. And so Linus wanted a new version control system solution for working on the Linux operating system. And that is a giant project with thousands of collaborators that is distributed all over the world. I think Linux is one of the premier examples of a phenomenal success for open source software, meaning you can clone the Linux repository in Git and have the entire history of the Linux development on your computer, and you can work on Linux yourself. And this might be something you do in an operating systems class. And so Linus invented this, and this is sort of his second big, massively important contribution to the software world. In the last decade, Git really beat its competitors at the time. I grew up on Subversion, which was contemporary in the 2000s. Like at UNC, we were using Subversion in the mid 2000s. Both Subversion and CVS were centralized. There was a contemporary competitor with Git called Mercurial in the late 2000s that actually was popular at some other places. And there was a real competition, but Git ultimately won out. So why did Git win? Primarily for its speed and for its distributed nature. And it made some really nice computer sciencey decisions down at the core, which we'll talk about as we learn how Git models its commits and its history. But it's remarkably fast. I remember the first time I started using Git and carrying out some operations that I was used to doing in Subversion and thinking like, wait, did that actually just do what I think it did? Because it was instantaneous and I'm used to this taking like 30 seconds to a minute. And my mind was blown. And so it's remarkably fast. When you give a Git command, it happens just about instantaneously. Even when you're moving files up and down from the internet, it's incredibly fast compared to what its competitors were doing before. The distributed nature of it is really cool. It's really cool that you're not entirely dependent on an internet connection in order to do work. That you could be on an airplane and working on a project that's in Git and not have to like navigate getting Wi-Fi or something in order to check a file out from a server. And the fact that the entire repository is local to your machine when you're working on a Git project is what helps make it really fast. It's immutable by default. And this is important because it gives you extra confidence that when you start carrying out actions, you can always go back to some previous state. When something's immutable, that means like we can't go back in time and reconfigure some commit we made earlier. If we revert something that we did before, we tend to make a new commit that reverts those changes, but we can actually see the entire history along the way. There are ways of mutating your history in Git, and some of them are useful, but we're going to save talking about those until later because they're also dangerous, and you want to know what you're doing if you're mutating your history. But by default, Git is immutable, so you're safe to carry out the typical workflow that you would with a high degree of confidence that you can always go back. And if you were at risk of doing something that might overwrite some history that would cause you to lose some work potentially, Git prevents you from doing that, or you have to go out of your way to do it with intention. It's append only, and this is very similar to the benefit of being immutable. That means we're always moving forward and making new connections. That means we can always go back as well. And it's really robust. It's got checks built in that ensure the integrity of your data. In fact, what's really cool that we'll learn very soon is every time you make a commit, it has some identification associated with it. And that identification is actually a hash, just like you've seen in a hash table in a data structures course. It's a secure hash of the commits that came before it and the contents of the commits that came before it, as well as the files that you're working on now. And so you've got a high degree, because the identification of every commit is based on the contents of that commit and the history, you know that you've got a high degree of integrity in your data. And this is a really cool idea we'll come back to. So what is GitHub versus Git? We've heard of GitHub. You've got a GitHub account most likely. Git is the version control software that is managing all of these changes behind the scenes. It's an open source piece of software. It's written in the C programming language. You can go download its source control and its source repository and build your own Git or modify it if you wanted. You install this on your computer. It's local. Whereas GitHub is primarily a website that is both a social website, but I think it's become more of a collaborative and corporate or academic website where people share their projects. And even though Git, as I mentioned, is decentralized and everybody has their own copy of a Git repository, GitHub offers a central place that's really easy to navigate to set up profiles and your keys, and to easily collaborate on. It's got other features that are great for projects, like tracking issues that exist in a project or having a sort of a to-do list of what's going on in a project, and really great ways for doing code review. And we'll talk about those things later on. But it's mostly a social website where you are able to interact and collaborate with others and back up your Git repositories too. You can use Git without GitHub. There's no requirement that you use GitHub in order to use Git. There are other services that are competitors with GitHub, including Bitbucket and GitLab, and I believe there's one other that's around and popular. but it's become sort of the de facto standard, and they've got great support for academia, and that's why our projects at UNC tend to be hosted on GitHub. But you can use Git just on your computer without any connection to GitHub at all. You can share code between each other without using GitHub. These two things are separate from one another. However, GitHub is dependent on Git for pushing your changes to it or pulling from it or collaborating on it. If you don't already have a personal GitHub account, you should go ahead and set one up. And I'm going to encourage you to add your full name, add your location, whether it's Chapel Hill or if you're not here right now, that's fine too. Maybe add UNC as an affiliation, or if you've done an internship and you want to add that there, I think having your affiliations there is good. When you're in the process of recruiting and interviewing people for internships and full-time jobs, your GitHub profile might be something they do look at, and having the default picture that isn't really you and it's just the default just looks low effort. And so we encourage adding a profile picture of yourself. And I'm going to encourage you to add your UNC email address to your account as a secondary address, even if you signed up with a personal email, just for our bookkeeping on the back end of this. So that's a high-level overview of version control systems and Git. Next, we're going to get into how do you actually use Git and think about it from the bottom up.